Now we turn our attention to perfect links or reliable channels. So perfect links, these are channels that deliver any message sent exactly once. So exactly one. So it's a reliable channel. Let's look to the specification of perfect link, the interface. So here we have the module, perfect link point-to-point link with the instance component PL. And our events still the same as usual. Now we are just using perfect links. So a process can send a message to a destination and the message is M. So this is a request for the transmission of a message M to a process or a node. Then we have the output event, which is the delivery of a message M, given that the source is, here is the source, given that this is the source. And this will deliver the message M sent by the process or node source. And we have a number of properties that we are going to discuss now. So what are these properties? The first property is reliable delivery. And what does it say? It says if PI and PJ are correct processes, then every message sent by PI to PJ is eventually delivered by PJ. So as long as the two processes are correct, message sent by PI will be delivered by PJ. Second, we have the no duplication property, which says every message is delivered at most once. And then we have the no creation properties, which says no message is delivered unless it was sent. So the network does not deliver messages that are not sent. So the first question that we want to discuss is which one of these property is safety and which one is aliveness, or neither. So let's look at the first property, reliable delivery. Reliable delivery is delivery by a process to another correct process, and that message will be eventually delivered. So if neither PI nor PJ crashes, then every message sent by PI to PJ is eventually delivered by PJ. So now, is it aliveness or safety? That is the question. This is aliveness property. Why? Because as long as PI and PJ are correct and PI sends a message, we can always extend the current execution so that that message is delivered by PJ. So now let us look to no duplication. Is it a safety or aliveness property? It is a safety property. Why? Because the bad event is the second delivery of a message sent by PI. If we do a second delivery, then that is a bad event. Now let us look to no creation, which says no message is delivered unless it was sent. What about this property? This is again a safety property because the bad event is the delivery of a message M by PJ that is not sent by any other process. Now let us look to a perfect link implementation. And here we are going to do a naive implementation. Naive implementation, but it's a compositional implementation. So we are going to use a stubborn link, and we use that to implement a perfect link. So again, here is the send, and here is the deliver, and here is the send, and here is the deliver. So we use a stubborn link. And then we add to each component of the perfect link a log. And this log is a record of all messages that has been delivered to that component, delivered to PL. So all received messages will be in this log, and the log is called delivered. And then it's simple. If you get a send request, you forward the send request to the stubber link. So a send request comes here, will be forwarded to the stubber link. And if the stubber links outputs a deliver event, then we are going to check the log delivered, and only deliver messages that were not delivered before. So that is the idea. And again, let us look quickly to the correctness property of this reliable delivery. This is guaranteed by the stubber link. In fact, the stubber link will deliver the same message infinite number of times. So this was a stubber link delivery property. No duplication is guaranteed by our log mechanism, because we do not deliver any message up if it was already in the delivered log. And the no creation is guaranteed by the stubber link property, and of course by its loss link property or lossy link property. So this implementation looks like to be a very inefficient implementation, but it is possible to implement a more efficient version based directly on fair loss links and repeated sends based on timeouts, and I will leave this as a subject of discussion. The delivered log, on the other hand, could be compacted if a delivered message may imply the delivery of previous messages. One possible way to implement this is to add some kind of ordering or sequence number to messages. So now let us go to another type of perfect link, which we call the FIFO perfect link, or reliable FIFO perfect link. What are the properties of a FIFO perfect link? It has a reliable delivery, has PL1, it has no duplication, and no creation. But then we add an extra property, which is called FIFO perfect link property, and this is called order delivery. So let us see what this means. It says if a message M1 is sent before M2 by PI to PJ, and M2 is delivered by PJ, then M1 is delivered by PJ before M2. So I think this is clear. If you deliver M2, you must have delivered M1. That is the order delivery property. So now let us discuss the relationship between the known internet TCP protocol and our FIFO perfect link. So a FIFO perfect link is some form of idealization of a TCP. TCP provides reliable delivery of packets, but TCP is also session-based, which would mean between two alive processes there will be a session, and during that session messages are delivered, in this case packets actually, are delivered in a FIFO order. But once the session is cut for any reasons, then messages are dropped. So once the session is dropped between two processes and the processes are alive, a number of messages may be lost or dropped. In general, TCP use a sequence number, and in fact an implementation of also FIFO perfect link could use a sequence number. And what this sequence number says, it's some kind of acknowledgement which says I have received everything up to the byte X. So you don't need to have a big log for storing messages, or in this case packets that has been delivered. Now implementing a perfect link abstraction on TCP is possible, but this requires reconciling messages between the sender and the receiver if the session is dropped and when you re-establish the connection, you have to reconcile these messages. This ends our treatment of process and channel failure modes. In the rest of the lectures, we are going to assume a perfect link most of the time in the course until otherwise specified. And as I said, roughly, reliable links or perfect links ensure message exchange between correct processes are delivered exactly once, as long as there is a connection or a session between the processes. And just to make it clear, in our treatment, we assume that messages are uniquely identified with some global ID. And the identifier includes the sender's identifier. If the same message, by same message I mean message with the same content, are sent twice, these two messages are considered different. Many algorithms for crash recovery process model assumes either a stubborn link or a logged perfect link. We are not going to discuss so much crash recovery except on the consensus lecture.